All right, Algebra 2, sorry we are gone at tennis today, but we are going to go through the 8.5 notes. So kind of your hint for 8.5, draw out a diagram for every single problem, especially the word problems. There's a lot of numbers that go on in your head. It's easy to mix up that sine, cosine, tangent, whatever that is. Some new verbiage for us. If we have a triangle, so here's the triangle that we've been working with the last couple days. This normal angle that we have is called the angle of elevation. And then, let's say there's an airplane flying in the air. If they talk about the angle of depression, that is just the angle from kind of like where you're looking at the airplane to the airplane. If there's like an imaginary horizontal line right here, but these two angles are the exact same angle. So if they tell you to find the angle of depression, just find the angle of the elevation, just like we have in triangles all week long. It'll be the same thing, okay? And then just remember SOHCAHTOA. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. All right, so our first example, they want us to solve for theta. So this is kind of that angle of depression that we were talking about earlier. Maybe you can see that a little better. So we have our hypotenuse is 914 feet. The vertical side is 381 feet. And we want to find this theta up here, this angle. Well, we know that the angle of depression and the angle of elevation are the same thing. So we can really find this angle right here. We don't need to worry about that. Just find that angle right there. Okay, that's pretty simple. Opposite over hypotenuse, that's sine, so in SOHCAHTOA, so just take 381 divided by 914. But when we want to find the angle right here, we have to take inverse sine. So theta is inverse sine of 381 divided by 914, and you can find inverse sine, that sine with the little -1 up in the exponent, by hitting the second button and then the sine button on your calculator. And then Savas will want you to round it. So my answer was 24.6 degrees, and then just round that up to 25 degrees. And then the last two problems we're going to talk about, we want to find the area of these triangles. So they're going to give us some information here. They tell us that we have an angle of 24 degrees and then two sides of 26 and 46 feet. Well, this formula right here is going to help us find an angle really easily. Again, I would start with drawing a diagram just so you can see it. Capital letters represent the angles, lowercase letters represent the sides. So in our example, we have side C would be 46, B would be 26, angle A is 24, just like they told us in the givens. We're just going to plug those values in for these variables. So our area is 1/2 times B times C times sine A. And you can mix around these variables if you have to, if you have different givens. But these are just the givens that we have. So as you can see, we just plug them into our equation, type it into the calculator, and off we go. Make sure for our label we have feet squared or inches squared or whatever unit they tell us. And then here's kind of a longer one. Again, we want to find the triangle, but they give us 3 sides instead of 2 sides in an angle, so it makes it a little trickier. Let's start with drawing our diagram. We don't know that angle yet. That's why it's in green. Come back to it later. But we have 31, 23, and 27. And I just always call this A, this B, and this C. So like AB is the side AB right here. That's 31 because it's between the angles A and B. BC right here is 27. And then AC is this side on the right side. That's 23. Well, we know from, it would have been last class, the law of cosines. Maybe you can see it better like this. The law of cosines is that C squared equals A squared plus B squared minus 2 times A times B times cosine of angle C. Well, our letters are a little different, so we're just plugging in kind of those sides. I think on your Savas, they might give you like L, K, and M. But if you do need help, Just use that question help button to kind of get your letters straight. But these letters just represent the sides. So usually our sides are like the lowercase letters. Here they have A, B, B, C, and AC. Just trying to trick you. But our end goal is to find this theta, as we do right here, because then we can plug it back in to our area equation to find area. Okay, so let's just kind of start over. We start with the law of cosines. We're going to plug in all of our numbers. As you can see, AC was 23, AB was 31, and BC was 27. So we're just plugging in our values, and we still don't know theta. Well, all these values are going to be really simple to calculate. They're just squared in your calculator or multiplied together like right here. I think it helps to write it out just so you visualize it. You need to subtract these two numbers over, and we'll have eventually negative 1,161 equals negative 1,674 times cosine theta right here. We are solving for theta, so we need to get everything over to the other side. We need to cancel it. Let's divide by it because it's multiplied. And that gives us this fraction. So when we divide this, we have 0.6935 equals cosine theta. And if we are solving for theta, we just need to take the inverse of cosine of that decimal, and that's going to tell us our angle. And our angle is 46.1 degrees. So back in our diagram, I just filled in that 46.1 into our triangle. And once we know this angle, we can plug it in to this equation right here from our last problem. That area equals 1/2 times B times C times sine A. And as you can see, when we plug this in, that's that same equation. There would be like our B, C, and angle A. We have 301.6. They did not tell us if it was like feet or inches, so we're just going to say units squared. Okay? If you guys have help, send me an email. I should have my phone on me, but I will do my best to get back. And then we will review and answer questions tomorrow.